Hi, everybody. Today what we're going to be working on is we're going to be looking at distance time graphs. And so what you'll see on one of your axes, your vertical axis, is distance. And we're going to be measuring what the distance traveled, for instance, is on the first few graphs over time. So what you'll see on your horizontal axis is your t, your time. So what we're going to deal with is our time being our independent variable, and distance being dependent on time. And what we want to look at are three components of each distance time graph, or three properties of it. So what we're going to focus in on then is going to be the first thing. We want to look at how we can interpret distance on a graph. Secondly, we're going to look at the other component of a distance time graph, time. And lastly, what we do is we want to look at the relationship between distance and time, that being speed. And so we're going to look at those three components of each graph, or properties of each graph, as we move forward. So what I'd like you to do is just take a look at the graph that I've put on the screen right now. And you'll notice that what we're doing is we're measuring distance in meters, that being distance traveled, and we're measuring time in seconds. And what I've done is I've put on a red graph to represent a certain relationship dealing with motion. You'll notice that I have a few important values recognized on my distance axis, and the same with my time axis. What we're going to focus in on for this graph is that first component, distance. The first thing I'd like you to notice in the red graph is that it can kind of be broken up into maybe three sections. That you might be able to see that red graph with the ability to kind of break it down a little bit to say that maybe this first section I might call like section A. And then the second section, something seems to happen along here at B. And then we have this curved section at the end. We'll call that kind of segment C. And so what we're going to do is we're going to break down our distance components over those three sections. And so if we were asked to answer the question, how far did you travel? If this graph was to represent you traveling in meters over time in seconds, then for us to break down each one of those segments, we should be able to look at that graph and be able to answer that question for all three segments. So what I'd like you to do is to pause the video for a second, give it a shot, try answering those three. Okay, we're back. And so as we scan through segment A, we should be good that we started traveling at a distance of 0. The fact that it wasn't labeled, we can see that our graph begins at the origin. And then segment A seems to end at this point. And so if I was to track that back to what was my distance, I have now moved from 0 to 3. Over that segment A, I move 3 meters. Hopefully we match up. We then take a look at that segment B, and we notice that B begins where A finishes and seems to end right at that point. If we were to answer the question, how far did you travel in segment B, I'm hoping that we put down 0 meters. My distance did not change. It began at traveling 3 meters, and it ended at traveling at 3 meters. Lastly, for segment C, hopefully we saw that we began at 3, and as we progressed and worked our way through, segment C finishes in this location, which would be at a distance, that's a very sloppy line, of 10. And so at the beginning of C, we were at 3. At the end of C, we were at 10. We then traveled a distance of 7 meters. Hopefully we matched up and we were good to go on distance. And so if we move backwards and we take a look at that exact same graph, and we can then break it into those same segments, but this time start to examine time on the graph. then maybe we get to the point where we can answer the question, how long, as in time, was each, and we can say segment, or we could say each action for whatever that person was doing. And so in segment A, B, and C, we should be able to say how long was that person acting in each one of those sections or segments. So what I want you to do, pause the video again, jump in and give all three a shot. Okay, we're back. And so we should be good at breaking down the individual segments now. And so as we take a look, segment A finishes at this point, which began at a time of 0 and ended at a time of 2. Therefore, we traveled for 2 seconds. Now we take a look at segment B. Segment B began where A finished and ends at that time. And if I scan down, I notice that it ended at 5 seconds. And so segment B went from 2 to 5, and therefore it lasted 3 seconds. And if I do the same thing for segment C with that curved line or curved segment, then I know that C began at 5 and it finished at 9. Therefore, segment C lasted 4 seconds. Hopefully we match up and we're good. And now what I want to do is I want to take a look at that third component, speed. And so if we were to look at that same graph again, what we would be trying to answer is how fast are you going or traveling? And so we could do that exact same thing, examining what happens over segment A, B, and C. The important thing for us to note is when we are talking about speed, what we are talking about is a rate of change. And you know from previous work that when we examine rate of change, what we're really examining is slope. And so in this instance, what we are looking at is how does our distance change? And so we can refer to that sometimes as like a delta D, some of you guys who have already taken science. And then you work your way through and you say delta T. And so what that really references is the change in distance over the change in time. That is us examining, well, how fast are we going, and therefore speed. So to take a look at that first segment then, we should be really good at being able to break down the components of speed, distance, and time. In segment A, we notice that we traveled 3 meters, so our distance changed by 3 meters, but it took us 2 seconds to do it. And so if I take a look at my rise over my run, then that would be 3 over 2, and we could convert that into a decimal and describe it as 1.5. We know that on all rates of change, it requires units, and so what were my units in distance on top? Meters. And what was my units in time on the bottom? Seconds. And so our speed was 1.5 meters per second. So what I'd like you to do, pause the video and give the next 2 a shot. Okay, we're back. And so as we examine, and I'm just going to label those segments again, we should be really good at them by now, but when we go to examine segment B, the big part for us is that we should have got down to an answer of 0. Now, when it's 0, it doesn't require any units. However, it's probably a good thing for us to also include those units and say we're traveling at 0 meters per second. How do we get to the 0? Well, notice segment B started here and ended here. And my distance was the same at both of those times. And so when I go to calculate my slope, I had 0 rise. And so it really doesn't matter what number I'm dividing that by. If time has passed and I've traveled no distance, then my speed was 0. We may have got down to the point where we actually said 0 divided by 3 and then converted that to 0 meters per second. We examine that part C, that segment C, and we notice that it started here and it finished here. Well, we've already dealt with that part, so we notice that we've traveled a distance of 7, and it took us 4 seconds. The biggest part that I want us to get to is that we don't have a line for segment C, that we have a curve. And so really the only thing that we could answer, and we'll examine this closely, is what the average speed was. And so if we got down to an average speed of 1.75, put on your units, meters per second, and I think we're doing great. What I want to do is I want to kind of remove that curved aspect of things. And so we're going to jump in and we're going to examine a couple other things pertaining to speed. And so as we kind of break down 2 of those segments, I want to examine them closely. First off, segment A and B both have something in common. Segment A and B, because each one of those segments is a line, then we know that the speed is constant. Now in A, everywhere in segment A, my speed was the same because I have a line. B, it almost seems the same, almost even like a trick question at times, but my speed is constant. Throughout that entire segment B, I am traveling a speed of 0 meters per second. However, when we get down to segment C, we should notice that our speed has been changing, or our speed is changing. So it is not constant. I want to jump in and I want to examine maybe a little more closely why C is changing, or the speed is changing. But it requires us to take a look back at section A. Because A is linear, then it doesn't matter if we travel this amount of time to travel this amount of distance. Because it is linear, no matter where I go on that line, I am traveling over the same amount of time, the same distance. And if I'm traveling the same amount of distance over the same amount of time, then my speed is constant. However, we can see that in graph C, that will not always be the case. So what I want to do is I want to jump in and I want to examine just something that looks like segment C, a curve specifically. And I think to be able to do that best, what I want to do is I actually want to remove the curve first. So let's examine a graph that's entirely made up of line segments. So let's take a look at this new graph, and all I've done is I've put in a different segment C, changing everything to line segments. So the first thing we notice then is over all 3 segments, our slope is constant. And because of that, that means that our speed is constant. So all I want to do is I want to focus in on segment A and segment C. And if we were to go through and do a quick calculation on what was the speed in segment A, then we should be good again to say that my slope is my speed, it is my rate of change, and so I traveled a distance of 3, it took me 2 seconds, therefore my speed was 1.5 meters per second. Now to take a look at segment C, I want you to pause the video and do a quick calculation on speed just for segment C. Okay, we're back. And so in segment C then, we should have gone through and said that we traveled a distance of 2 meters and it took us 4 seconds to do it, and therefore we had a speed of 0.5 meters per second. And so hopefully that matched up and we're good on calculating speeds. The second thing I want to get to, though, is how we can start to compare speeds without our calculations. You can see the numbers on the right in gold for what the speed was in segment A and segment C. But I'm hoping that we can tie together a really big idea when we look at our graph. Steeper means faster. What that means was we were rising faster than what our run was, relatively speaking. Now, you can see that a little bit on segment A and segment C. We traveled faster during segment A, 1.5 meters per second. We traveled slower on C, only a half a meter per second. And therefore, we were traveling faster in segment A. Segment A is a steeper line than what segment C is. That also then, if we look at it the other way, flatter means slower when we're talking about speed coming from distance time graphs. So, huge portion for us and a huge thing for us to be able to look and interpret a graph quickly. Steeper means we're traveling a faster distance over a given time. Slower, flatter, means we're traveling lesser of a distance over a given time. So let's put that idea, and now let's take that concept and let's jump into a curved graph. Okay, so let's take a look at that curved graph. And let's just use a little bit of terminology from earlier on in the unit. What we're going to examine then is a non-linear graph. And so we're not going to make speed calculations this time, but what we want to do is have the ability to be able to look at a graph and examine the slope, even though our graph or our slope on the graph is changing. So I'm going to put an awful lot of dotted lines on the graph. And I want us just to slow down for a second. Maybe this is a part of the video where we kind of go back and take a look at again. But we're going to make this diagram a little uglier as we start to break down certain segments of this graph. Okay, the first thing I want to do is I want to kind of chop, let's look at it as almost like segment A in half. So we're going to say that segment A starts when time equals 0, and it ends when time equals 5 seconds. So the first 5 seconds of this segment, we're going to call A. I'm going to put that A way up here. Now, what I want to do is I want to kind of chop segment A in half, just as an example so we can see it on our picture. So what I'm going to do is I'm going to chop it in half, not by time, but I'm going to maybe chop it in half a little bit of a different way. So it's going to look weird because if it is a 5-second interval, then I'm going to chop it in half at maybe 2.5 seconds. So maybe somewhere in here. So what we're going to examine then is the first half of segment A and the second half of segment A. So I'm just going to get rid of that blue line. And what we're going to do is we're going to examine the first half of segment A. So if we were to examine the speed during that segment, then I would have to calculate slope. And what I notice is it is going to take me 2.5 seconds to travel this little bit of a distance. And so if I was to calculate the slope of that, I notice that I'm going to have a pretty small number divided by 2.5. If I was then to examine the next 2.5 seconds, that means that I'm going to travel the same amount of time, so the bottom of my slope calculation would be the same, but I traveled a much greater distance. And so if I was to go through and calculate slope, on the green portion of segment A, I traveled a farther distance during its time, 2.5 seconds, than what I did in the blue segment of segment A. I traveled a very little distance over that 2.5 seconds. We should be able to see then that the slope of the green is going to be greater than the slope of the blue. And so when I examine that, then, I know that I am moving faster in the green section than what I am in the blue section. Slope is speed. And so as I now examine the entire segment A, I notice that over the whole course of segment A, if the second part was faster than the first part, then my slope, which I know means speed, is increasing. And so you could make the argument then that over the course of section A, segment A, I am speeding up. And so when I happen to see a graph that curves upwards like this, where it becomes steeper as I move along, then I know that that means slope increasing. And we should be able to translate that then to speeding up. Now let's take a look at the next segment. I want you to be able to put in your mind right now that we can interpret what's going on with slope. So if we examine the next segment, we should see that if I went a certain distance, then I am going to go, a certain time, I will travel a certain distance. But in the next segment, I might travel the same amount of time and less distance. And given our discussion from before, where we see that the second segment is actually less than the first segment when we calculate slope, we may be able to make the conclusion pretty easily then that if I see a graph that is starting to curve down, notice my graph is still increasing to the right, but is starting to curve down, then that means that my slope is decreasing. And I bet I would have a bunch of people then that can draw the conclusion that therefore I am slowing down. If my curve starts to turn and go down, then I can see that my slope is decreasing and draw my conclusion. So hopefully that helps us to be able to interpret any nonlinear graphs. Okay, we're going to address one more graph, and that graph is going to have a little bit of a different look to it. We're going to pick up the pace a little bit, but we're going to see how maybe we have to make a couple of adjustments. And okay, what I want you to do is I want you to take a look at the graph on the screen, and I'm going to give you a second just to try to take a look at it and interpret that graph. So the biggest thing that I want to draw to your attention is take a look at what your distance is being measured as now. We have changed what your distance measured is. And so in all the previous graphs, we've taken a look at distance traveled. And so as soon as I start at time equals 0, my distance was always 0. And then as we began to count time, my distance traveled increased. Well, now what we've changed on our vertical axis is I'm not measuring the distance traveled anymore. What we're measuring on this graph is distance from home. So I want to put a scenario in your head. And let's imagine that this is you, and somebody is going to say, I'm starting the clock right now, and I'm going to measure what's going to happen to your distance from home over the next 12 minutes. And so I hit my stopwatch, and we begin counting time. And so I want you to interpret that graph under that scenario. Then what I would like you to do is I would like you to try to go ahead and answer for those 3 segments, A, B, and C. Can you calculate the speed for each? I think if you're good to calculate the speed, then I could clearly ask you a question to be able to interpret distance or time. So I would like everybody stop the video right now, see if you can calculate the speed for segments A, B, and C, and we'll see if we match up in the end. So we should be back. And hopefully what we came up for A is we noticed that we went up 60 for A. So when we take a look and we try to interpret that speed, we need to know our change in distance. And so we went up 60 meters, and it took us 4 seconds. So if I was to go through and then actually like eliminate those arrows in a way, we then had a run of 4 and a rise of 60. And so to calculate our slope, I have my change in distance over my change in time, and we should have got down to 15 meters per minute. If we then examine section B, well, I had no change in distance, so I have a 0 divided by, and we might have taken a look and said that we went over for 1 second. That gives me a rate of change of 0 meters per minute. And on section C, we then began here and fell. So we went down, and notice we went down 80, and we went across 7. And so for us to calculate, that's then going to give us approximately, so if I round off, 11.43 meters per minute. So hopefully as we work our way through, we can match up and we can see what we came up with. Now, a couple kind of things to highlight. First off, I want you to notice segment C. When we ask the question, what is the speed? Speed is always positive. Always. So don't be alarmed if you had had a negative 80 over 7 when you calculated the speed on segment C, because you said that your line segment was going down as we move to the right. No problem. We can make that correction and we're good. Couple things to use as a check. Segment A's graph or section is steeper than segment C's. So when I calculate its speed, I should have a higher number in A than C. I check that. Everything matches up. Okay, the last thing that I want to notice is we could actually describe the motion in this case. So if you were to give me some sort of explanation for what that graph would represent, we could say that in segment A, our distance increased from home. And so therefore, we started away from home. So maybe we're at a neighbor's house, 20 meters away. And when we started time, we actually walked away because our distance from home increased. Maybe in segment B, we stopped for a second. Well, it only took 1 minute. So maybe we stopped in our position. We heard our name get called and tell us to come home. We had to tie our shoe. Whatever happened in that minute, we did not change position. We stopped. And then in segment C, my distance from home decreased. And so I went from being 80 meters from home to being 0 meters from home. That means that I was walking towards my home. There we go. I think that puts together everything that we need to know to be able to interpret distance, time graphs, and make sure that we can work those things together to be able to determine speeds. Okay, your job now, jump in and work through your stuff on your weekly schedule. Hopefully things go well. Good luck.